Hello friends, welcome to Experiment Academy. In the last lecture we have completed the discussion on the equation of central axis. Okay, so in this particular lecture we will start discussing problems on the equilibrium of forces in 3 dimension. Okay, so let's start our discussion. So before proceeding further, let us discuss few concepts that are required for solving such type of questions. Okay, so let's start our discussion. Okay, so we have the conditions for the single resultant force. Okay, so we have supposed that a system of forces acting at different points of a rigid body. Okay, so we have a rigid body. Okay, and we have a system of forces. Let us take few points. Okay, now these points are, let us name this. So this is point 1, this is point 2, this is point 3, this is point, let us take this as n. Okay, and we have a system of forces. So let us take O as the origin of vectors. Okay, and we have the position vector of these points as, this is r1, this is r2, this is r3, and this is rn. Okay, and since we have system of forces, so let us take this as f1, this as f2, this as f3, and this as fn. Okay, we have the system of forces acting at different points of a rigid body reduces to a single force r acting at a arbitrary chosen point O. Okay, so this is our arbitrary chosen point and a couple G. Okay, so this reduces to a single force R and a couple G. Okay, then the necessary and sufficient conditions of this system of forces to reduce to a single resultant force. Okay, so this whole system reduces to a single resultant force, reduces to single resultant force. Okay, this means G, the value of G, okay, that is couple of moment is equal to 0. Okay, this obviously this reduces to a single resultant force. This means couple of moment is 0. This means there is no moment. Okay, so what are the conditions? So the conditions here are Lx plus my plus nz is equal to 0 and x square plus y square plus z square is not equal to 0. Okay, so these are the conditions for the single resultant force. Okay, now let us recall our discussion on the pitch. Let us calculate pitch. Okay, now let us consider a rigid body like this. Okay, and we have a arbitrary chosen point as AR. Okay, and the position vector with respect to O, that is base point, is R vector. Okay, now we have changed the base point from O to O dash. This is O dash, and we have taken O dash vector as C vector. Okay, at point O, let us consider the resultant as R and couple of moment as G. Okay, we have changed the base point from O to O dash, so we have the resultant as R dash. Let us take this as, and couple of moment as G dash. Okay, so we have studied that on changing the base point from O to O dash, there is no change in the resultant, that is resultant will remain same. So R is equal to R dash, but the couple of moment is not same, that is it gets changed from G to G dash. Okay, and we have G dash is equal to G minus C cross R. Okay, now let us calculate the value of pitch. So we have the relation as pitch is equal to, G is equal to pitch times of resultant vector. Okay, now let us find G dash. So G dash is equal to P times of pitch times of R dash. Okay, and we have, let us take dot product with R dash. So G dash dot R dash is equal to P times of R dash dot R dash is equal to P times of R dash whole square, and we have R dash is equal to R, so this is P R square. Okay, and we have, from the concept of invariant, G dash dot R dash is equal to G dot R. Let us replace this. G dot R is equal to pitch times of R square. So from here we have pitch is equal to G dot R upon R square. Okay, and we have the value of g as g is equal to L I cap plus M j cap plus N k cap, and R is equal to X I cap plus Y j cap plus Z k cap. So G dot R is equal to Lx plus My plus Nz. Let us place the value here. So pitch is equal to Lx plus My plus Nz upon x square plus y square plus z square. Okay, so this is the value of pitch. Okay, so now let us proceed further on the discussion of questions. Okay. Okay, so let us start discussing the problems. Okay, so in the question number 1, a single force is equivalent to component forces x, y, z along the axis of coordinates and two couples L, M, N about these axes. Prove that the magnitude of single force is given by x square plus y square plus z square under root, and the equations to its line of action are given by this particular expression. Okay, so let us solve this. So we have a single force. Okay, so what we have studied that the conditions for single resultant force, resultant force is Lx plus My plus Nz is equal to 0, and we have x square plus y square plus z square is equal to not equal to 0. Okay, so what are these x, y and z? So x, y and z are resolved component of forces along Ox, Oy, Oz respectively. Okay, so x is the resolved component of forces along Ox, y is the resolved component of forces along Oy, and z is the sum of resolved component of forces along Oz. Okay, so this we have discussed couple of minutes ago. Okay, so now we have the equation of central axis as, okay, so we have, and these L, M and N are sum of moments, okay, along this Ox, Oy, Oz respectively. Okay, so we have the equation of central axis as L minus, so let us have a trick for remembering this. Okay, so we have, let us write down x, y and z. Okay, and now again we have x, y and z. This is x, y, z, x, y, z. So first we will take y, z. Secondly we take zx. After that we will take xy. Okay, so we have yz for writing the equation of central axis. This is yz, this is zx, and this is xy. Okay, so let us write down the equation of central axis. So we have L minus, let us take y, small y capital Z, plus again small z capital Y upon L. Okay, now let us take zx. This is equal to m minus z capital X plus x capital Z upon m, and this is equal to n minus xy. This is x capital Y plus y capital X upon n. Okay, and this is equal to, this is not visible I think, and this is equal to Lx plus, this is equal to Lx plus My plus Nz upon x square plus y square plus z square. Okay, so this is the equation of central axis. Okay, and the condition here for the single resultant force is this is equal to 0, and obviously this is not equal to 0 because this is in denominator. So since this Lx plus My plus Nz is equal to 0, the whole expression is 0. So we have L minus y capital Z plus Z capital Y upon L is equal to 0. So this means L minus yz y capital Z plus Z capital Y is equal to 0. So from here L is equal to y capital Z plus Z capital Y. Okay, similarly M is equal to, similarly this is L, so M is equal to M is equal to Z capital X minus X capital Z. Okay, and N is equal to, okay, so we have N is equal to X capital Y minus Y capital X. Okay, so from here, from these expressions, let us divide this by, so from here Y capital Z plus, sorry, this is minus, okay, so this is Y capital Z minus Z capital Y upon L is equal to 1. Okay, similarly from here Z capital X minus X capital Z upon M is equal to 1. From here we have X capital Y minus Y capital X upon N is equal to 1. So all these are equal to unity. Okay, so we can equate all these. Let us equate this. So we have Y capital Z minus Z capital Y upon L is equal to this one. This is X, this is small z, Z capital X minus X capital Z upon M is equal to X capital Y minus Y capital X upon N. Okay, so this is what we have to prove. The equations of line of action are given by this particular expression. Okay, now we have to prove that the magnitude of single force. Okay, so we have component forces are the component forces along X, Y and Z as this is capital X, capital Y and capital Z. These are the component forces along coordinate axis. Okay, so we have the resultant as R is equal to X I cap plus, because this is resulting to a single resultant force. Okay, so this is R is equal to X I cap plus Y j cap plus Z k cap. So R will be equal to under root of magnitude of R. So this is X square plus Y square plus Z square. Okay, now let us discuss question number 2. Okay. So we have the equal forces act along the coordinate axis and the straight line given by this particular expression. Find the equations of central axis of the system. Okay, so we have how we can solve this. So let us draw the diagram first. So we have equal forces act along the coordinate axis. Okay, so we have the coordinate axis like this. Equal forces act along the coordinate axis. Okay, so this is X. Let us take this as X, Y and this is Z. Okay, and we have and the straight line. So this is our straight line. So this is equal forces. So there are 4 forces. So 3 forces are acting along the coordinate axis and the fourth one is along this straight line. Okay, so this is our straight line. So equation of this is X minus alpha upon L is equal to Y minus beta upon M and is equal to Z minus gamma upon N. Okay, so the direction cosines are L, M and N. Okay, and we have a arbitrary point here as, let us take the point as arbitrary point as alpha, beta and gamma. Okay, so now equal forces act along the coordinate axis and the straight line. Okay, so we have the forces as, let us take this forces as P. So the force along x axis is P, force along y axis is P, force along z axis is P, and force along this line, this one is P. Okay, so we have 4 forces. So force 1 is along, this is force 1, this is along OX, force 2, this is force 2, this is along OY, this is force 3, this is along OZ, and this is force 4, this is along along this line, this is along this line. Okay, So now we have to now let us write down the equation of the central axis. Okay, so the equation of central axis is how we have remembered this. So we have the x, y and z. Okay, again write x, y and z. So let us take yz, zx and xy. Okay, so this is yz, this is zx and this is xy. So we have the equation of central axis as L minus y capital Z plus Z capital Y by L is equal to, now let us take Zx. So this is M minus Z capital X plus X capital Z upon M. This is equal to N minus X capital Y plus Y capital X upon N. Okay. So this is the equation of central axis. Now we have to calculate the value of L, M and N, and we have to find components of forces along OX, OY and OZ respectively. So this is capital X, capital Y and capital Z. Okay, after finding the value, we will put these values in the equation of central axis. So this is the equation of central axis. Okay, so for this we have to construct a table. Okay, let us draw the table for calculating the value of L, M, N. Okay, before that let us calculate these values, capital X, capital Y and capital Z. Okay, so capital X is sum of component of forces along x direction. Okay, so we have the forces along x direction is this one P, and this is P. So the component of this force P along this line along x axis will be P times of direction ratio. So direction ratio along the direction ratios are L, M and N. Okay, so we have the component of force P along x axis will be P times of direction ratio, that is L. Okay, component of force P along y axis will be, let us recall that at component of force P, that is force P is along this one, that is force 4. Okay, so the component of force 4 along y axis will be P times of M. Component of force 4 along z axis, this is P times of N. Okay, so we have capital X is equal to, this is P plus PL. Okay, and we have capital Y is equal to P times of M, PM, and Z is equal to P plus P times of N. Okay, so capital X is equal to P1 plus L, capital Y is equal to P1 plus M, and capital Z is equal to P1 plus N. Okay, so these are the values of capital X, capital Y and capital Z. Okay, so now let us calculate the value of L, M and N. Okay, so now let us construct the table for this. So for this we have point of application of forces, and secondly we have component of forces along OX, OY and OZ. Okay, so we have the forces as force 1, force 2, force 3, and this is force 4. Okay, so let us take this force 1 is along OX, force 2 is along OY, force 3 is along OZ, and force 4 is along this particular line. Okay, so this line is x minus alpha upon L is equal to y minus beta upon M is equal to y minus gamma upon N. Okay, so now we have the point of application of forces. Let us take the coordinates as x1, y1, z1, x2, y2, z2. This is x3, y3, z3. Okay, let us write down again x3, y3, z3, and this force 4 is point of application of forces. This point is, this point is here. Okay, this is alpha, beta and gamma. Okay, in the question it is written as, okay, so the straight line is given by this particular expression. So the point force Force 4 will act at alpha, beta and gamma. Okay. So now the point of application of force 1 is origin. At origin the force 1 is acting. So this is 0, 0 and 0. Okay. Force 2, this is force 2. This is acting along y axis. So the coordinate will be 0, 0 and 0. Force 3 is acting along z direction. So the point of application is origin 0, 0 and 0. And force 4 is acting along this particular direction, that is along the straight line. So the point of application will be alpha, beta and gamma. Sorry, this is x4, y4, z4. So x4, y4, z4 is point of application of this force along this line. Okay, so this is alpha, beta and gamma. Okay, now we have the component of forces. Okay, so component of forces is, so force 1. So the component of force along the force 1. Okay, so the component of forces along OX, OY and OZ. So along OX we have the force SP. Okay, along OY this is nothing, 0, 0. Okay, for force 2 the force is along y axis, so this is 0, P and 0. For force 3 this is along z axis. Okay, so the component of force is 0, 0 and along z axis we have P. Okay, now for force 4 we have the components as this one, PL, PM and PN. So this is PL, this is PN, this is PM and this is PN. Okay, this is not forces, this is actually force. Okay, so this P is this force along the component of force, that is component of force along OX. So this is P and there is no component along y axis. Okay, so the component of force 1 is only along the OX. There is no component of force 1 along OY, that is y axis and z axis. So we have kept 0 here. Similarly for force 2 is along y axis. So there is no component of this force 2 along x axis and z axis. So we have kept 0 and 0 here. Only we have P component. Similarly for force 3, we have, there is no component of force 3 along x and y. So we have kept only P here, that is force along the z direction. Okay, now for force 4, the force is along this particular direction. So we have to take the component of this force along OX, OY and OZ. So the component of this force P along OX is PL, component of this force P, that is force 4 along the y direction, that is y axis, is PM. Similarly, component of this force 4 along z direction is Pn. So we have PL, PM and Pn. Okay, so now let us calculate the value of L, M, N. Okay, so this is L, this is M and this is N. Okay, after that we will put in this particular expression. Okay, so for calculating L, M and N, what is the trick? For calculating L, let us hide this one. Let us hide this one. And we will do the cross multiplication. This 0 times of 0 minus 0 times of 0. Similarly, 0 times of 0 minus 0 times of P. 0 times of P minus 0 times of 0. Beta times of Pn minus, because we have hided this. Okay, this one is hide, this one is we have hided, this one we have hided, this one we have hided. So beta times of Pn minus gamma times of Pm. Okay, so let us write down. So we have L is equal to 0 times of 0 minus 0 times of 0, 0. Similarly, this is 0. This is 0 times of P minus 0 times of 0. So this is 0 plus this is beta times of Pn, minus gamma times of Pm. This is equal to P times of beta n minus gamma m. Okay, now we have the value of m. For finding m, we have to hide okay, so we have to hide this one. this one we have to hide, this column we have to hide. Okay, so now let us take the cross multiplication. So cross multiplication will be like this: 0 times of p minus 0 times of 0. This is 0 times of 0 minus 0 times of 0. This is 0 times of 0 minus 0 times of p. This is gamma times of pl minus alpha times of pn. Okay, so this is 0 plus 0 plus 0 plus this is gamma times of pl, gamma times of pl minus this is alpha times of pn. This is equal to p times of this is gamma l minus alpha n. Okay, now let us find the value of n. How we can find this? So for this, okay, so for this we have to hide the third column. Okay, so let us hide this. So this we have to hide, this we have to hide, this we have to hide, and this we have to hide. So the cross multiplication will be like this: 0 times of 0 minus 0 times of p, 0 times of p minus 0 times of 0. This is 0 times of 0 minus 0 times of 0. This is alpha times of pm minus beta times of pn. Okay, so let us write down this. So we have this is 0 plus 0 plus 0 plus this is alpha times of pm, alpha times of pm minus beta times of pl. So this is equal to p times of alpha m minus beta l. Okay, so these are the value of l, m and n. Okay, so let us write down at one place. So we have the value of capital X as capital X is equal to p times of 1 plus l, capital Y is equal to p times of 1 plus m, capital Z is equal to p times of 1 plus n, and we have L is equal to p times of this is p times of beta n minus gamma m. Okay, m is equal to p times of gamma l minus alpha n, and n is equal to p times of alpha m minus beta l. Okay, now let us place all these values in this one. So we have L, the value of L is this one. So p times of beta n minus gamma m minus y times of the value of z is this one. So this is p times of 1 plus n upon plus z times of capital Y. Capital Y is this one, p times of 1 plus m, okay, upon L. The value of L is p times of beta n minus gamma m. Okay, and this is equal to, let us further simplify this. So this is equal to, let us place values in this one. So we have m minus, so m is this one. So this is p times of gamma l minus alpha n minus z times of capital X. Capital X is this one. This is p times of 1 plus l. Okay, plus x times of z. Capital Z is this one. This is p times of 1 plus n upon we have the value of m as this one. So this is p times of yl minus alpha n. Okay, and this is equal to last one. This is n minus. So value of n is this one. So this is p alpha m minus beta l. Okay, n minus x times of capital Y. So capital Y is this one. This is p times of 1 plus m, p times of 1 plus m. Okay, plus y times of capital X. Capital X is this one. This is p times of 1 plus l upon we have the value of n. N is p times of alpha m minus beta n. Okay, so this is nothing but the equation of central axis. Okay, so this is all about the problems on the equilibrium of forces in 3 dimension. Thank you.